Ever wondered why some metals explode in water while others just sit there looking pretty? That's all thanks to the Activity series of metals, a super important list that ranks metals from most reactive at the top to least reactive at the bottom. It's like the popularity chart but for metals in chemistry. Let's start at the top. Potassium and sodium? These guys are the life of the party. Drop them in water and, whoa, you get an instant fizz, heat, and even explosions. Calcium's a little more chill but still reacts with water. Moving down, you hit magnesium and aluminum. They need more energy, like hot steam, before they'll really show off. Now, in the middle, there's zinc and iron. These metals won't react with water, but they'll still bubble up with acids. For example, zinc plus hydrochloric acid gives you zinc chloride and hydrogen gas. Boom! Classic chemistry experiment. But as you slide down to copper, silver, and gold, these metals are basically chemistry introverts. They don't react with water or acids. Gold's so unreactive it just sits there looking shiny and expensive, no matter what you throw at it. So how does this activity series actually work in real life? First, it predicts what'll happen if you mix metals with water. Highly reactive ones like sodium split water and bubbles of hydrogen zoom out. Less reactive metals need steam, and the ones at the bottom, forget about it. Second, it helps with acids. Metals higher than hydrogen on the list, like magnesium and iron, react with acids to make salts and hydrogen gas. But copper, silver, gold? Nope, acids barely bother them. And here's a cool trick. Displacement reactions. A more reactive metal can kick a less reactive one out of its compound. For example, if you drop zinc into copper sulfate, zinc takes copper's spot, making zinc sulfate and leaving copper behind. But try the reverse. Copper into zinc sulfate, and nothing happens. Why does any of this matter? The Activity series helps me predict which metals to use for things like batteries, metal extraction, and even stopping rust. That's why iron rusts like crazy, but gold stays flawless. So next time you see a shiny metal or a rusty nail, remember, it's all about where they sit on the Activity series.